Hello everyone. In this video we will see the response of the low pass filter with square input. Actually till now we have seen the low pass filter output for different inputs. For example, low pass filter circuit is like this: series connection of resistor and capacitor we have to take, and output is to be observed across the capacitor, and input is applied here. So, we have provided actually sinusoidal signal, output is again sinusoidal signal only, but there may be changes in the amplitude levels, there may be changes in the phase, but shape of the signal is sinusoidal signal only. So, that we can able to tell linear wave shaping cannot be possible using this particular sinusoidal input for the linear circuit. Okay, wave shaping will not be done for the sinusoidal signal as input for the linear network. Okay, that is what we can able to observe, but you can able to see the changes in the amplitude levels and phase. Then we have provided here step input as the signal for the low pass filter. Because of the step input, what type of output you got? Exponentially increasing signal you got. Okay, and expressions we have given for this one, that is V into 1 minus e power minus t by RC, where V is the step change in voltage in the input, that is from 0 volts to V volts, there is a change in the input levels. So, for this particular step input, the output is exponentially increasing signal, and maximum voltage in the exponentially increasing signal is V only. Okay, when you take t is equal to infinity here, then what will you get? E power minus infinity is 0. So, 1 minus 0 is 1, 1 into V is V. That means finally it will reach up to V volts only, but in the form of exponential way the output is increasing. And sometimes you may get output like this also, immediately it may reach V volts. Sometimes you will get this V, to get this V, particularly V volts, it will take larger amount of time. That means very long amount of time it will be taken by the output to reach this V volts. Here 3 cases are there. Okay, for example, if you assume this is a T1, capital T1 is a specific time instant. Okay, so in this particular case what is happening? In the first case, in the second case, in the third case, in the first case reasonably how much amount of time is taken to get V volts, that is approximately equal to T1. Okay, but here T1 is available, T1 is a fixed value in all the cases. Okay, T1 is a fixed value. For example, T1 is equal to 5 seconds I have taken. So, to charge up to V volts also, in the first case it has taken 5 seconds only. That means to charge up to V volts 5 seconds is required, and T1 is also 5 seconds. You are observing the output at T1. So, if you see at 5 seconds time, then output is equal to V volts in the first case. Next, if you take the second case, here T1 is equal to 5 seconds only, but here one thing you need to observe, the output already reached V volts. Okay, output has been reached this V volts before t is equal to T1 only. In the first case, exactly at t is equal to T1, the output reached V volts. In the second case, output reached V volts before the T1 only. Before the T1 seconds only, output reached the V1. But in the third case, even after T1 seconds is completed, output did not reach V1. You see, at t is equal to T1, output levels is not reaching T1. Is not reaching T1, it has reached approximately V by 2 only, it not reached V. Okay, it reached just V by 2 at t is equal to T1. In all the 3 cases, T1 is equal to 5 seconds, 5 seconds, 5 seconds only, but in the first case exactly at 5 seconds it reached V volts. In the second case, before t is equal to T1 only, that means before 5 seconds only, the output reached V volts. In the third case, even after completing the T1 seconds, that means 5 seconds, output did not reach V volts. Okay, so to reach V volts in the third case, it took longer time than the T1. Next, in the second case, it took less than T1, and in the first case exactly it requires T1. Why it is happening like this? But the mathematical expression in these 3 cases we are giving in a single way, that is V into 1 minus e power minus t by RC. The same mathematical expression in all the 3 cases, output is given by V times of 1 minus e power minus t by RC only. But where is the difference here? Where is the difference means that is very important point, that is RC. Based upon the time constant, the time taken by the output, okay, how much fastly it will reach the V volts will be decided. Okay, how much fast or how much delay is required to reach this V volts by the output is decided by the time constant value RC, the product of resistance and capacitance. Based on that, the output can reach immediately, the output may take longer time to reach V volts. Okay, based upon the time constant only different outputs we can able to get. Based upon the same concept, now if you apply this particular pulse input, now if you apply instead of the step input, if you apply the pulse input means in our previous classes already we have seen this pulse input is maintaining the constant voltage V volts at T is equal to Tp. This is what we have taken. Okay, and the corresponding outputs also we have taken, and for your convenience once again I will draw here. So what we will get, in order to draw the outputs, all of you required to make this input reference. That means with the dotted lines you can able to draw the input. So here 0 Tp, 0 Tp seconds, 0 Tp. On x-axis time is there in all the cases. Okay. Now, for example, here if I take RC is very much lesser than Tp, RC is comparable to Tp, here RC is greater than, that means very much larger than Tp. How you will get the output? Generally for the low pass filter, we may get a one triangular shaped signal, approximately a triangle, exponentially increasing and decreasing nature is there. How did we get all those things? Already I have explained in the last video. So that now we will see once again, just I am repeating the previous concepts in order to start the square input. Okay. So now we will see how the outputs will come with this particular pulse input. As time constant is very less, what is the meaning of time constant? Time taken by the output to reach 63.2% of the output. Time constant refers to 63.2% of the output only, because 1 minus e power minus 1 leads to 0.632. Why did I take this value? 1 minus e power minus 1 is 0.632. Actually, the output equation is given by V times of 1 minus e power minus t by RC. RC is fixed, E is fixed, 1 is fixed, capital V is fixed, but T is the variable. So, if you take T is equal to tau, that is equal to RC, here RC by RC means 1 will become, that means 1 minus e power minus 1, whose value is given by 0.632 times V, that means 63.2% of the V can be obtained if you complete one time constant amount of time. But in this case RC is very small, that is the condition we have taken. So, Tp is this one, Tp is this much is available, but condition refers to RC is just less than Tp. For example, in order to explain in a better way, I am taking numbers here. So, Tp is equal to 5 seconds, so RC is equal to 1 second you take. So, if it is 0 to 5 means here 1 second is there. So, within 1 second, what is the meaning of this one? Within 1 second, since RC is equal to 1 second, within 1 second the output can reach 63.2% of the output, final output. Final output means here final value, otherwise final value. Final value is V. Okay. Now, this is V means 0.632 V will be here. So, to reach this value 0.632 V, it will take 1 second only, because we have taken RC is equal to 1 second. So, by the completion of 1 second, the output reaches 0.632 V. Okay, here I have indicated the point, and after that slowly it will reach V volts. So, slowly it will reach V volts like this. That means actually immediately it has reached. Okay. In order to say in a better way, in order to try in a better way, just I am erasing this one and once again I will draw. So, within 1 second it reached 0.632 V. After that it is continuing to charge up to V volts. Okay, what is the meaning of this one? Before reaching T is equal to Tp seconds only, it reaches the V volts. Okay, like in the previous case whatever we have seen for the step input also, like this we got, and it is continuing this V volts like that. But exactly T is equal to Tp, input is removed. Okay, because the supply voltage is becoming 0, we can able to tell the voltage source has been removed, voltage source has been short circuited, like that we can able to tell. Whenever supply is not there, the capacitor starts discharging, that means output voltage will be decreasing and becoming 0. So, this type of output you will get when you take RC is very much lesser. Okay. Now if you take RC is exactly equal to TP, that means what is this TP? We have taken previously 5 seconds. So TP is equal to 5 seconds. So what is the meaning of RC? Whatever it may be the RC value, but if you complete RC seconds, it will reach just 63.2% of the final value. So this is V volts, this is 0.632 V. So by the completion of the 5 seconds, it will reach only 0.632 V. So like this will get. Okay. Then what is happening? If you complete after this T is equal to TP, okay, then it has reached just 0.632 V. It tries to charge up to V volts. Okay, output is try to increase up to V volts, but due to the this particular discontinuity in the input level, now the output will be decreasing. So like this will get. Okay, so it here somewhat it is looking like our exponential signal only. So I will redraw this one. So we can able to take like this exponentially increasing signal, like this we can able to get. Okay. Now coming to the next case, RC is very larger than 5 seconds. For example, RC is equal to 5, TP is equal to 5 seconds we have taken. Okay. RC is larger than TP means we can take 10 seconds. So here 5, so that here 10 seconds will be there. So 10 seconds is required for the output to charge up to again 0.632 V only. Okay, in the first case just 1 second is enough to charge up to 0.632 V. In the second case 5 seconds is required to charge up to 0.632 V, and in the third case 5 seconds 10 seconds is required. Okay, RC is larger we have taken. So 10 seconds is required to charge up to 0.632 V. So generally if you don't have the discontinuity at T is equal to TP, it will take 10 seconds. Okay, it will take 10 seconds to charge up to 0.632 V, but exactly 5 seconds what is happening? Because of the discontinuity in the input is becoming 0, so that whatever the stored energy is there in the capacitor will be released to the resistor. So capacitor voltage will be decreased, so that you will get a triangular shaped signal you will get in the last case. Okay. So in this manner you will get different outputs for the same pulse input only, that is based upon the different RC values. So RC is very lesser than the TP, RC is comparable with TP, and RC is greater than TP. And here one more thing I will take. If you take RC is equal to 4 seconds and TP is equal to 5 seconds, as usually I am taking TP is equal to 5 seconds. Okay, when you take equally, these two are equal in the second case, we have seen how the output will come. But when you take RC is 4 seconds, how we are going to get? I am going to draw now. So see carefully. I am taking the pulse input 0, 5 seconds, that is TP, this is T, this is V. Okay. Now what we have to understand? RC is now 4 seconds. This is V. So 0.632 V is here. So within 4 seconds, because RC is equal to one time constant, that is equal to 4 seconds, within 4 seconds it can reach up to 0.632 V. Okay, 0.632 V. So like this you will get. Then what is happening here? It is continuing to charge like this, then it will be decreased. Next, if you take in some other way, for example, TP is 5 seconds and RC is equal to 3 seconds. So this is 3. So within 3 seconds, the output can reach 0.632 V. Okay, 0.632 V, and it is charging up to V volts like this. Then it will start discharging, because after T is equal to TP there is no input. Okay, so like this also you will get. So based upon this, everything is based upon the RC value only. RC in comparison with the TP, you have to see whatever the time you are considering with respect to that time, whether RC is very less or RC is greater than that particular time instant, or RC is comparable. Comparable means you no need to say exactly equal. Okay, you can say if a TP is 5 seconds, you can say RC is 4, RC is 6, like that you can able to take. So based upon the RC value in comparison with the TP, different outputs you will get. Okay, now for the pulse input we have seen the output. Now we will coming to the exact topic today, that is basically square input. Okay, so before going to start exactly this operation of the square input, first we have to understand with respect to square input. So, here I am taking one particular square input here. If you observe this square input, you can able to see it is the repetition of the pulses only. Okay, it is the repetition of the pulses. For one pulse, we know how the output will come. For one pulse, we know how the output will come. A series of pulses are there. So, whatever the output we are getting, in case of one pulse, that output can be taken in a continuous manner, because here series of pulses are there. So, that we can able to take series of responses of the pulse input to get the output of the square input for the this low pass filter. So, very simple thing, concept is very simple thing, because we are working with linear circuit. If you add two inputs, then the corresponding outputs will be added. We know about the additivity principle, we know about the scaling principle of the linear system. According to that one, okay, here I will write that one. So, based on linearity principle, square input is a combination of pulse inputs combination of pulse responses. Pulse responses means do not think that output is pulse. Pulse response is nothing but with the pulse input whatever the response we are getting, that one. Okay. So, combination of all the responses which are due to the pulse inputs is nothing but square response. That means, square response is nothing but with the square input whatever the response we are getting. That is what we have to see. That means, for the pulse input you are getting for the low pass filter. For example, if you take here low pass filter, what is the output you are getting? Based upon the RC value, you are getting like this. Now, if you take the series of pulses like this, what will be the output? Series of the triangular pulses you will get. This is the output of this particular square wave. Again, based upon the RC value, in different manner you can able to get immediately the pulse, the output can reach the view also, like that you can able to take in a different manner. So, immediately it can reach, immediately it can discharge, immediately it can charge, immediately it can discharge, like this you may get. Now, in this case, as RC is very lesser than the T/2, T/2 means half of the time period. So, when you compare with respect to half of the time period, approximately square wave you are getting. Okay, that means wave shaping is missing here, wave shaping is missing. Okay, somewhat we got, okay, output is somewhat different from the input, but almost equal. That is why we can tell wave shaping is not occurred here. But whenever if you take RC is very larger in this particular case, what will happen? You see, what will happen means, so it will take larger time to charge, it will take larger time to discharge, like this you will get triangular wave you will get. So, this is when you take RC is very much greater than the T/2. So, like this we are taking. Okay. So, in this particular case, what did we get here? Square wave you have applied, but output is triangular wave. That means it is the integration of the square. Okay, triangle is equal to integration of square. This one we are getting when you meet this condition. RC is very much greater than T/2. Okay, very much greater than the T/2. The triangular output you are getting with the square input. With the square input you are getting. That means the low pass filter is acting as the integrator. Here low pass filter is acting as the integrator. Okay, low pass filter is equal to integrator. This one we can able to get when you take the time constant is very large. Okay. Now, we will go to the this particular derivation. So, when you take low pass filter, capacitor, resistor, here square input we are providing, and here as per the time constant we can get different outputs. So, you may get like this. Okay, you may get like this. So, now our purpose is to get the voltage levels of this output wave. Okay, the voltage levels of this particular output we need to get. So, as I said, we need to understand about the symmetrical square wave first. Symmetrical square wave. Symmetrical square wave is nothing but, if you take the square wave like this, whatever the positive portion level is there, same amount of negative portion will be available, including the duration. If it is available for t1 seconds, it is also available for t1 seconds. If it is total time period t, we can take 2t1, t is equal to t1, or t1 is equal to t by 2, like this we can able to take. Okay. And voltage levels also, if you take the voltage level, the peak to peak voltage is V, the positive peak is available as V by 2, negative peak is available minus V by 2. Okay, this is about the symmetrical square wave. If you are not meeting these conditions, we can tell that is the unsymmetrical square wave. Okay, the square wave may be available entirely above the x-axis or entirely below the x-axis, means DC content is available. Okay, and for the symmetrical square wave, we can define one more parameter, that is duty cycle. Duty cycle is equal to T on by T on plus T off. Okay. For example, if you take t1 seconds like this only, T on is for t1 seconds by, it is T on is t1 seconds, T off is also t1 seconds. That means t1 by 2t1, that is equal to 1 by 2, that means 0.5. If you want to tell in percentages, percentage of duty cycle is equal to 50%, then we can tell that is available for the symmetrical square wave. In this way we can able to tell. Okay. Now we are going to see the derivation. Okay, derivation part in order to get the voltage levels of the output. Okay, so we can able to get at what time how much amount of voltage is there. For that we have the derivation part. Derivation of voltage levels in output of low pass filter with square input. Okay, so I am taking the output, but here I am considering unsymmetrical square wave. Unsymmetrical square wave, then we can able to take the conditions of the square wave, symmetrical square wave, then you can able to get the exact outputs for the symmetrical square wave also. Okay, so first we will consider the unsymmetrical square wave. So what will, so this is the time axis. So unsymmetrical square wave means I am taking, here it is started, this is the t on, and I am assuming t on is a smaller time compared to t off. So t off is for longer time, so that I can able to tell here duty cycle is less than 50%, because t on is smaller than the t off. So I am representing the 2 cycles or the 3 cycles like this. Wait, is continuing like this, and entire signal is above the x-axis, means positive DC is also available in the signal. Okay. Now see carefully, this signal starts at t is equal to 0, that I have represented here. Then this upper level of the signal is available for t1 seconds, and lower level is available for t2 minus t1 seconds. Then total time period is given by t, that is equal to t1 plus t2, like this we have taken. Then voltage levels, lower voltage level I am taking as V dash, upper voltage level will be V double dash. In the textbooks also they have represented like this only, so we can able to use the same notations without any confusions. So we have taken like this. This one with respect to input only I am talking now. Unsymmetrical square wave we have taken as the input for the low pass filter. Then on time is different from the off time, that is t1 and t2 respectively. Total time period is equal to t1 plus t2, and the voltage levels of the square wave are also totally positive, because entire signal is above the x-axis. Those levels are V1, V dash and V double dash. Now I am going to draw output wave. Okay, so I am drawing the output wave like this. Charging, discharging, charging, discharging continuously, so we will get like this. So we can take here V1, this is V2, this is V1, this is V2, this is V1. So, first one is also V2, like this we can take. Here very important point I need to tell. So, if you observe this particular diagram, understanding of this particular graph is very important. Okay, listen carefully. This is actually we have drawn, whatever the output I have drawn with the voltage levels V1 and V2 can be obtained in steady state level. What is steady state? Steady state is nothing but after applying the input, certain amount of time is to be completed. Then the output is entering into the steady state. How much amount of time is nothing but phi time constants, phi tau, phi RC. This many seconds you need to wait in order to enter into the steady state. Okay. So, before this time, whatever the output is there, that is called transient output. Okay. When time is lesser than phi RC, phi RC is the fixed value because R is fixed, C is fixed, phi is fixed, but it is the variable. You have given the input, you are seeing the output, but you are seeing just before the phi RC only, then that is called transient. But when you reach this phi RC, that means you are observing the output when t is greater than phi RC, then the output is in steady state. Whatever the diagram I have drawn now, whatever the graph I have taken output wave with the voltage levels V1 and V2, those are related to this steady state only. Those are related to this steady state level only. So, whatever the derivation we are going to do now, that means we are going to get the voltage values V1 and V2. Those values are suitable for steady state voltage levels only. Okay. So, in this case V1, V2 are steady state voltage levels. That means after giving immediately the input, I am not seeing the output. I have given the input and I am waiting up to 5 RC seconds, that means 5 time constants amount of time. Then if you see the output, you are getting the in the output levels, always it is charged up to V1, discharging up to V2. What is the meaning of this transient and steady state is nothing but, as I said, in the steady state, the output always charged, or actually we can tell output voltage levels, because here capacitor is the output voltage, I can tell output is always charged, or capacitor voltage can be taken. Okay, I will remove this charge term. So, output always reaches voltage levels, same voltage levels. Output always reaches same voltage levels, V1 and V2. Very important. Okay. Because we are working in the steady state, the output always rises to V1 and falls to V2, that is compulsory. But what is happening to the output voltage levels when it is in the transient period? Output voltage levels are different in transient period. Okay, that means roughly here I am drawing, this is your like this I have taken. So, what will happen means output starts at 0, for example, charged up to this value, then discharging, then charges to some other value. You see this voltage level is different from this voltage level, then it is discharging like this. Previously it is discharged to 0, but now it is discharged to some other value, 0 in the sense this lower level. Now it is discharged to some other level. Now it is charged up to here. Next it is discharged up to here. Next charged up to the same voltage level. Next discharged up to the same voltage level. Here already it reaches V1, V2, V1, V2. From this time onwards, it is always charged up to V1, discharged up to V2. Okay, that means here it is entering into steady state. but to enter into the steady state it has to pass through the transient period. In the transient period, whatever the voltage levels, maximum voltage levels we are getting, those are different in every cycle. Okay, for example, it is 1 volt, it may be 2 volts here, it may be 0.2, now in this case it is 0.3. But after reaching the steady state, always V1, V2 values are same. Okay, and this derivation we are performing in the steady state only. Okay, so voltage levels all are equal. Why I am telling this one means there are some problems, okay, in the textbook. So you need to know this analysis. They may ask the question like this: find the steady state voltage levels of the output of low pass filter with square input, with the given square input. If they have mentioned a steady state, you need to do analysis like this only, by taking like this. Okay, if they want to ask in a tricky way, they may ask like this: find the voltage levels of the output of the low pass filter with the square input for the first 2 seconds, for the first 3 seconds, like that they may ask, or for the first 2 cycles of the input. Within that first 2 cycles, it may reach into the steady state, it may not reach into the steady state. That you need to analyze with respect to RC value. So this much particular concept is there here, very very important thing. Okay, very interesting also, somewhat confusing also. Okay, so whatever it may be, here we are going to work with the steady state voltage levels only. That means always the output reaches V1 and reaches V2. Okay, rises up to V1, falls up to V2. There is no change in the voltage levels. With that one, I am starting the derivation. So actually again this particular output wave I need. So again I am drawing here. So see carefully. So this is the input we have taken. On time is up to V1, off time is from T1 to T2. Total time period is T, that is equal to T1 plus T2. Voltage levels are V dash, V double dash. Okay, this is about input. Now if you take output in the steady state only I am considering. Always it rises to the same voltage levels V1, V1, V1 and falls to the same voltage levels V2, V2, V2 and continuing like this. Okay, and here we need to get V1 value, V2 value, that is our intention. Okay, so this is the curve, listen carefully, this is the curve, that means it is changing with respect to time. On x axis time is there, so I am giving the name for this particular curve, that is V01. Particularly we have to say V01 of t, curve 1 in the output, that is changing with respect to t. This is curve 2 in the output, output curve 2 changing with respect to time, V02 of t. So first curve, second curve. But what about this V1? V1 is the value of the curve 1 at t is equal to t1. V01 of t is the entire curve, that is representing the entire curve equation. So that is the variable because that is changing with respect to t. But V1 is the value of V01 of t at t is equal to capital T1. Okay, so V01 of t is curve. V01 of T1 is V1 value. You need to understand this one carefully. Similarly, V02 of t is the curve. So V02 of capital T, don't think that it is a T2. Okay, to get V2 value, we need to take t is equal to capital T because it counts from 0 seconds. So V02 of t is equal to V2. So like this we can able to analyze. So our intention is to get V1 and V2. For that, now we are going to write equations for V01 of t and V02 of t. Then we will substitute t is equal to t1 to get V1 and t is equal to capital T to get V2. Okay, that is the way of doing this particular thing. Okay, now I am writing the equation for V01 of t. So here I am writing, see carefully, V01 of t is actually exponentially increasing signal. Now capacitor voltage we have to consider. It is actually capacitor voltage only, capacitor voltage, because output in the low pass filter we are taking across the capacitor. So capacitor voltage is given by V final value plus V initial value minus V final value multiplied with e power minus t by RC. Okay, so here for simplicity I am taking only that particular curve now. So for this curve we are going to write the equation V01 of t. What is the peak value? What is the maximum value here? V double dash. It is V2. Okay, so in this way we have taken. This is V dash. So now listen carefully. What is the V final? What is the V initial? Okay, curve starts at, that means capacitor voltage starts at V2. Okay, you can able to see the waveform clearly. The output voltage or the capacitor voltage starts at V2. That means Vi is equal to V2. What about V final? You don't think that V final is V1. Okay, V final means, what is the meaning of that one? Means if you maintain the same constant input, okay, the capacitor can able to charge up to that voltage. That means there is a chance for the capacitor to charge up to V double dash. That is the final value. Okay, we are maintaining the input voltage V double dash. Because of the discontinuity, it charged up to V1 only. Okay, it is charged up to V1 only. Otherwise, if there is no discontinuity, it can charge up to V double dash. Okay, because input is V double dash just before the discontinuity. If you maintain the V double dash only, the capacitor can charge up to V double dash. That's why the final value we have to take V double dash. But the curve starts at V2. So initial value is V2. You need to understand these two carefully. Then you can substitute in the equation. So V01 of t is equal to V final is V double dash plus V initial is V2 minus V final is V double dash multiplied with e power minus t by RC. If you understand this one, we can able to proceed. Now I am rewriting this one by taking V double dash is common. So V double dash is available here, here also it is available. So from the first term we will get 1, from the second term we will get minus e power minus t by RC. Remaining is V2 term is there, so V2 into e power minus t by RC. Now write equation for V1. As I said, V1 can be obtained by substituting t is equal to, small t is equal to capital T1 in this particular V01 of t. So V01 of T1, t is equal to T1 I am substituting. So that you will get V1 value that is equal to V double, wherever t is there you write capital T1. Okay, so V double dash into 1 minus e power minus T1 by RC plus V2 into e power minus T1 by RC. Now we got the equation for V1. This is equation 1. Now similarly you write equation for V2 of t. Okay, so V2 of t is also the capacitor voltage. Okay, again I am taking the basic general equation, that is V final plus V initial minus V final into e power minus t by RC. But if I write t by RC, that is wrong, because this particular V02 of t curve is starts at t is equal to T1. It is not starting at t is equal to 0. Okay, this is not exactly available like this. It is available from T1 seconds onwards. Okay, so it is not available like this, it is available like this. You are writing the equation for this curve, but this curve is not starting from t is equal to 0. This curve starts at t is equal to T1. That means this curve is e power minus t by RC, means this curve is e power minus t minus T1 by RC. That means delayed version. You are shifting this particular signal to the right side by T1 seconds. That means delayed version. So here you have to take e power minus of t minus t1 by RC. Okay. Now what is the final value? Final value is nothing but V02 of t is equal to, now you see it can discharge up to V dash plus, as I said previously, V2 is not the final value. If there is no discontinuity from V dash to V double dash, it can discharge up to V dash. So that I have taken V dash. Okay. Next, plus V input is, it is coming from V1. So V1 minus, again V final value is V dash multiplied with e power minus of t minus t1 by RC. As I said in the previously I said that in the V02 of t, that means in this particular equation, if you take t is equal to capital T, you will get V2. Okay, V2 is the voltage level of the output at t is equal to capital T actually. Okay, so you take that one, V02 of capital T is equal to V dash, here you can take V dash common also. So if you take V dash common, 1 minus e power minus of, in place of small t you need to write capital T, listen carefully, in place of small t you need to write capital T, but what is there here, capital T minus T1 is there, so that you will get here T2. Okay, by RC. Now I am writing remaining terms, that is V1 into e power minus of, again same thing we will get, that is T2 by RC. Okay. So what is the meaning of this one? You are substituting t is equal to capital T means you are looking for V2 equation. So this is equation 2. Equation 1 represents V1 value, voltage level of the output. Next, equation 2 represents V2 value, that is also voltage level of the output. Now equation 1, you don't see all these exponential values V dash, V double dash, e power minus T1 by RC, e power minus T2 by RC. Okay, don't see like this. These are just two equations with two unknown values V1 and V2. Known values are V dash and V double dash, because that is the input voltage levels. Okay, so V dash, V double dash, known values. T1, T2, T, RC are also known values. That means you can take constants, constant values. Okay, so for your understanding purpose, here simply I will give one representation here. See carefully. If you observe this first equation, V1 we don't know, V2 we don't know, because I don't know that I can take that one as a variable or unknown quantity x. V1 is equal to, that means x is equal to V double dash, I know that is also constant, multiplied with 1 minus e power minus T1 by RC, everything is constant. So I can take one number like 2 plus V2 I don't know, that means another variable. I have taken V1 means x. Next, this V double dash into 1 minus e power minus T1 by RC is constant, I am taking 2 plus V2 is nothing but y. Next, e power minus T1 by RC means again constant, I am taking 3. Okay, just for example purpose I have taken. This is equation 1 now. Now you observe equation 2. V2 I don't know, but V2 means already I have considered y, that is equal to, next V dash into 1 minus e power minus T2 by RC, everything is constant. V dash we know that is the voltage level of the input signal, that is known to us. V2 is constant, RC is also constant. So this everything is constant, I can take 4 plus V1 means already I have assumed x. Next, e power minus T2 by RC I can take, for example any 5, for example 5, whatever it may be. Now you see equation 1 and 2 are similar to these two equations only. Now I can rewrite like this, x minus 3y is equal to 2, 5x minus y is equal to minus 4. You see how these equations are there. It is easy to solve these two equations. Similar thing we have to perform on these equations also. Don't confuse here by seeing all these V dash, V double dash, e power minus T1 by RC, T2 by RC. Okay, don't confuse. This analysis is looking like this particular note point only. Okay, solving very simple linear algebraic equations only. Okay, now what we need to do, how to solve this one? Generally what we will do, take y from this one, substitute here in terms of x. That means the equation, this equation will become only in terms of x, then you can get x value. That x value you can substitute in the next equation, you will get y value. Same thing we are going to perform here. Okay. So, already we have V2 from equation 2, we have V2 value. Substitute this V2 value in equation 1, then you will get in terms of V1. That is it. V1 you can able to obtain like that. Okay. That is what I am going to perform here. So, do not confuse by seeing all these equations, very simple procedure. Okay. It is like solving two linear algebraic equations only. Okay. So, that I am taking this V2 in equation 1, what will happen you see now. So, V1 is equal to V double dash into 1 minus e power minus T1 by RC plus V2. V2 means what is there here? This everything is there. This entire thing we have to multiply with according to equation 1 e power minus T1 by RC. So, simultaneously I am multiplying with e power minus T1 by RC. See carefully. V dash into 1 is multiplied with e power minus T1 by RC. So, V dash into e power minus T1 by RC. Next, minus V dash into, from equation 2 we have e power minus T2 by RC. From equation 1 we have e power minus T1 by RC. Bases are equal, powers will be added. T1 plus T2 means T we will get. So, e power minus T by RC we can write. Okay, next term. In place of V2 we have to write V1. Okay. So, V1 plus V1 into e power minus T2 by RC, but here again we have to multiply with e power minus T1 by RC, that means e power minus T by RC, like this we will get. Okay, now if you observe this one, here also V1 term is there, left side V1 is there, we are looking for V1 only. Send this one to the left side and take V1 is common. So, what we will get? V1 times of 1 minus e power minus T by RC, it is equal to, now I am writing the rest of the part to V double dash into 1 minus e power minus T1 by RC. Next, plus V dash into, you can take here e power minus T1 by RC common, then you will get, from this one you will get 1 only, minus from this one you will get e power minus T2 by RC, like this we will get. Okay. Now, this is for unsymmetrical square wave whatever we have considered till now. This part you can send into the denominator. V1 value you got it over. Okay. Because it is not having any variables now. You can able to observe V dash is constant, V double dash is constant, T1, RC, T2 all are constants only. So, we got now V1 value, the voltage level of the square output wave we got. If you substitute this one in equation 2, you will get V2 value also. So, derivation is over for the unsymmetrical square wave input, the voltage levels are obtained. Now, you take a symmetrical square wave conditions, symmetrical square wave conditions if you take, that is what we can able to tell, V dash is equal to minus V double dash. Okay. V dash is the lower level, V double dash is the upper level, because it is symmetrical. Symmetrical means like this now, it is V double dash, it is V dash. So, one is negative of other. If you take overall voltage level is peak to peak voltage is V, so we can take here minus V by 2, like this we can take, V dash is equal to minus V by 2, because that is the lower level. So, minus minus will be cancelled, V double dash is equal to V by 2, upper level. Next, T1 is equal to, T2 is equal to T by 2. Okay, on time is equal to off time, that is equal to half of the total period, like this we can take it. If you substitute all these things, then this equation will be modified. Okay, that equation we need to get. Okay, for that I need to write this equation in the next slide. So, now we are substituting all those values, T1 is equal to, T2 is equal to T by 2, next V dash is equal to minus V by 2, V double dash is equal to V by 2, like this we are substituting. Then V1 will become, what we will get we will see. Okay. So, V double dash means V by 2, V dash means minus V by 2. So, if you take V by 2 common, okay. So, what we will get? 1 minus e power minus T by 2 RC, because T1 is equal to T by 2. This is from the first one, minus e power minus of T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus 1 minus e power minus T by 2 RC, plus multiplied with 1 minus e power minus t by 2rc by 1 minus e power minus t by rc. Now you take these two terms common. So it is equal to v by 2 into 1 minus e power minus t by 2rc. So here 1 minus e power minus t by 2rc by this denominator 1 minus e power minus t by 2rc, sorry rc can be written like this: 1 minus e power minus t by 2rc, 1 plus e power minus t by 2rc. X minus y into x plus y is equal to x square minus y square, that means 1 square minus e power minus t by 2rc square, that means into 2. So you will get this one. So denominator can be written as the product of these two terms. So what did we get? 1 minus e power minus t by 2rc, 1 plus e power minus t by 2rc. This one will be cancelled. So v1 is equal to v by 2 into 1 minus e power minus t by 2rc by 1 plus e power minus t by 2rc. This is what we got. You can remember this equation. Try to remember this equation, and we are going to modify also that one. That is v1 is equal to v by 2 into here you can take e power minus t by 4rc common, because 1 is there, you will get here e power plus 4 t by 4rc. If you multiply these two, you will get 1 minus e power minus t by 4rc. If you multiply these two, you will get a e power minus t by 2rc only. By in the denominator also you take e power minus t by 4rc. So you will get e power t by 4rc plus e power minus t by 4rc. Like this you will get. These two will be cancelled, so that you will get v by 2 into the remaining part. But this part is looking like e power x minus e power minus x by e power x plus e power minus x. That is actually tan hyperbolic x, that is t by 4rc. Like this we will get. With this, derivation is completed. What about v2? v2 is minus v1. Okay, symmetrical square wave. So like this we will get v by 2 into tan h of t by 4rc. You need to remember the equations, final equations. You need to remember the procedure also, because based upon the problem, if they have given the symmetrical square wave, you can work with this particular condition. If it is unsymmetrical square wave, you need to remember this equation. Okay, instead of remember this equation, you can do the procedure. Okay, whatever the derivation procedure we have taken, that procedure you can apply in the problem also. Okay. So with this, I am closing this particular video. Thank you.